Now this section is on solving equations involving radicals. And in this particular case, I have the first two problems on the board for a reason, because I want to show you the difference, because notice what's inside the radical. What's inside the radical on this one is an x to the first power. What's inside the radical here is an x squared. And I'm going to show you when we get to the bottom, often you have a question is, when do I use that plus or minus? You're thinking you're solving an equation, so when you get down here you're going to think that you might want to use it, but I'll show you the difference why you're not going to want to use it. Now the object of these equations is you always isolate the square root on one side in equations that only have one. Get it all by itself on one side of the equation. This one's already set up that way. And the easiest way to solve these is to square both sides, because I know that the square root of a times the square root of a is equal to a. So if I square this side, I'm going to get 4x minus 3 is equal to, square this side, I get 5 squared, which is 25. Now I'm going to add 3 to both sides. I get 28 is equal to 4x, and x is equal to 7. Notice over here, it's a simple linear solution. I did not take the square root of x at all to get this over here, to get this 7. So it is a positive 7, and that's the answer. Now over on this side, when I square both sides, I get 2x squared minus 7 equals 25. And now add 7 to both sides, and I get 32 is equal to 2x squared. Dividing both sides by 2, I get x squared is equal to 16. Now I have to take the square root of an x squared to get this. So if I take the square root of this side, I get x is equal to, this is where you use the plus or minus square root of 16, which is equal to plus or minus 4. And you see the difference is because I actually took the square root of a variable over here. I did not take the square root of that variable. So this is when you use that. When you have other roots, you do the same thing with them, only instead of squaring them, I'm going to cube both sides when I get down to isolating this cubed root all by itself. So I get the cubed root all by itself by subtracting 5 from both sides. So I get minus 2 equals the cubed root of 2d. Now I'm going to cube both sides of this equation. If I cube this and cube this, remember negative 2 cubed is going to give me negative 8 is equal to 2d. Divide both sides by 2, d is equal to minus 4. Now sometimes when you do these equations and when you square them, you're actually going to get some extraneous roots. That's something you have to watch out for. So what you should do when you get to the bottom is always plug your roots back in and make sure they make sense and that they are a solution to the equation. And that's into the original one. Now squaring both sides up here, I get x plus 2 equals x squared. And now you solve this like any other quadratic. X squared minus x minus 2 equals 0. Factoring here, x and 2 and 1, and they are, the 2 is negative and the 1 is positive. So I get two answers here. X is equal to negative 1 or x equals 2. Now I plug these back in. Negative 1 up here, I say negative 1 plus 2, and I take the square root of that. Is that in fact equal to negative 1? Well, this is 1. Square root of 1 is 1. Well, 1 equal negative 1, not true. So I can throw this root out. So I put the square root of 2 plus 2 equals 2. And I get 4 here. And yes, the square root of 4 is 2. And this one checks out. So this is the answer to that problem. Now in this particular case, you want to isolate again the square root and get rid of the 1. So I'm going to put it over here, x plus 1, before I square both sides. Now if I square both sides, I get 2x plus 5 equals x squared plus 2x plus 1. Remember, squaring a binomial. Okay, now get everything, all your x squares. You got 2x on both sides, so that goes away. And I get a minus 5 over here gives me a minus 4, so I get 0 equals x squared minus 4, and this is the difference of two perfect squares, factors into x plus 2, x minus 2. So my answer is again negative 2, positive 2. Now we're going to put the original back into the original equations, both of these back in, and check them out. Is the square root of negative 4, which is the negative 2, plus 5 minus 1 equal to negative 2. Well, this is 1. Square root of 1 is 1 minus 1. Is that in fact equal to negative 2? No. So throw that one out. That one doesn't work. Now we take the positive 2. 2 times 2 is 4. Plus 5 is the square root of 9 minus 1 equal to 2. And 3 minus 1 equals 2. Check, this one works, so 2. Now the directions in this section of problems are giving you two examples. One is linear and one is radical. And what's the difference? The difference is if you have a variable inside of a radical sign, which you do in part A, then it's called a radical equation. If you don't, down here, it is not a radical equation. Just because you have a radical doesn't mean it's in a radical equation. This is a linear equation. Because as I told you before, root 2 is just a number. So up here, we have a root of a variable. So this is our radical equation. Now, the difference is, how do we solve these? We solve the radical equation just like I showed you. You take the 5 from both sides, and we get 2 is equal to 2 root x. Divide both sides by 2, and I get root x equals 1. Square both sides, x is equal to 1. And now when we get down here, and when we do the other one down here, we have to do the same thing here, and we get 2 over here, x times root 2. And now we're dividing not by the x, or root 2, we're going to divide both sides by root 2. So you're going to get x is equal to 2 over root 2. And now you have to rationalize that denominator, because you know you can't have a radical in the denominator. So we're going to multiply it by 1, which is root 2 over 2. And we get 2 root 2 over 2. Well, the 2's here cancel out. Remember, I have multiplication up here, so I can do that. And our final answer here is root 2.